Hello and welcome back to another video. Today we're going to be taking a look at some Euclidean geometry questions. Let's take a look. In the diagram, O is the center of the circle with a reflex angle of 230 degrees. P, Q, R and S are points on the circumference of the circle with chord SR extended to point T. They also give us some extra angles and it's given in the diagram. Calculate the magnitude of the following angles. Angle S. Okay, so to solve angle S, what we need to do here is we need to focus on this shape right here. Okay, we know that this is going to be the angle at the center, and we can then apply the angle at the center theorem. Angle at the center is going to be 2 times the angle at the circumference. So if that's 230 degrees, then that's going to be, so S is going to be half of it. 115 degrees. Next question, 9.2.2. Calculate angle Q. Now, to solve angle Q, what we need to do is we need to look at this entire shape right here. That is a cyclic quadrilateral. And we know that the opposite angles of a cyclic quadrilateral are supplementary, meaning that to get angle Q, we just need to say 180 degrees minus 115, and that gives us 65 degrees. Okay, the last one, P1. Now to solve P1, what we need to do is we need to focus on this exterior angle right here. R is actually the exterior angle of a cyclic quad. And there's a theorem that goes along with that. And the theorem is that the exterior angle of a cyclic quad is equal to the interior opposite angle. So P1 plus 20 degrees is equal to 85. That means P1 is equal to 65 degrees. Okay. Question 9.3. In the diagram, PQRS is a cyclic quad. QA intersects SR at point A. SAQ is 130 and AQR is 20. Calculate, giving reasons, the size of angle P. Now the way I'm going to solve this is by focusing on this entire shape right here. Now I know that it's a cyclic quad and the opposite angles are supplementary. So P plus R is 180 degrees. Now all I need to do is figure out R. And I can if I focus on this triangle right here. Now I can solve for R by simply using the property of a triangle, which states that the exterior angle of a triangle, this here, is equal to the sum of the interior opposite angles. So 20 plus R equals 130. That means R must be 110 degrees. Now if R is 110, that means P must be 70 degrees. Okay. Let's move on. So just ignore the diagram on the right. You'll see where it's used just now. Let's just focus on this. So the question reads, in the diagram, O is the center of circle ABP. PB is extended to C, AC is drawn, PN is a tangent, OC intersects AP. A whole lot of information here, right? But the important one we're going to focus on just for now is that P2 is 37 degrees. 10.1.1 reads, determine giving reasons the size of angle O1. Now, O1 is this angle right here. All right. Now, the way that we're going to solve this is first by focusing on this angle right here. That is an angle that a tangent is making with a chord. So we need to look for the tan chord theorem. So the chord is PB, and it's subtending this angle right here, which means that A1 is going to be 37 degrees as well. Now to solve O1, what we need to look for is angle at center theorem. So let me clear this up. Now, if I focus again on this chord PB, that chord makes an angle at the center, but that chord also makes an angle at the circumference. And so I can use the angle at center theorem. So the angle at the center, being O1, is going to be double the angle at the circumference, which is 37. So O1 is going to be 2 times 37, which is 74 degrees. Let's move on. 10.1.2, prove that OACB is a cyclic quadrilateral. This is where our diagram here is going to be useful. But before we go to that diagram, we need to focus on one thing. So let me just clear this up. If we focus on this line right here, that line is my diameter. And the diameter will subtend an angle at the circumference of 90 degrees. The theorem is angles in a semicircle. So this angle right here, B2 and B3, is going to be 90 degrees. Now, since B1, B2, and B3 form a straight line, we can then say that B1 is going to be 90 degrees. So let's put that in our new diagram right here. So B1 is 90 degrees. Now, it's not drawn to scale, but it's just to give us an idea. Now, all we need to do is we need to look for a very specific theorem here that's going to help us to prove that this is a cyclic quad. And the theorem is, let's focus on this chord here. That chord subtends 2 angles. This angle right here and this angle right here. That's the angles in the same segment. But the converse of the angles in the same segment helps us to prove that it's a cyclic quad. Because remember, the converse of this, the converse of the angles in the same segment tells us that if they are angles in the same segment, that's on the same side, then the 4 points will fall within a circle or will form a cyclic quad. So we've proven it here, and our reason is the converse of the angles in the same segment. Okay. Now the last question, OC parallel to PN. So it's not going to be that difficult. Let me show you why. So all we need to do here, let's clear this up a bit. All right. So let's focus on the lines. OC is this line right here, and PN this line right here. Now we know that angle O, O3, that's 90 degrees, it's given to us. And we also know that OP is a radius. Now the radius and a tangent will meet at 90 degrees. And if we just complete this, we can see the letter F, which tells us corresponding angles. So since P1 and 2 is 90 and O3 is 90, we can say that those lines are parallel because of corresponding angles. Let's move on to the last question now. The last question reads 10.2, in the diagram, PAT is a common tangent of the smaller and large circles at A. A and B is the diameter of the large circle with M on the circumference of the small circle. M is the center of the large circle. So important just to remember that M is my center. Next, they tell me it is given that the length of AM is P. So AM is P, that means MB must be P as well, because it's a radius. Then AS is P minus 1, so that's P minus 1. But we can't say that SC is P minus 1, because it's not a radius. Okay? Next, we look at the questions. Oh, one more thing. BC is 6. So this is right here is 6. Next, we go to the questions. 10.2.1 says, name giving reasons 3 angles equal to 90 degrees. Now, not too difficult. all we need to do is, we know that that's going to be my radius, and that's a tangent. We know that the radius and the tangent is perpendicular. Next, if we focus on the small triangle, sorry, the small circle right here, this line AM closes up on this angle right here. You could think of it as tan chord, but tan chord or angles in a semicircle. This angle right here, S1, is also going to be 90. I think the better option would be tan chord theorem here. Next, we can do the same thing, but for the larger circle, the circle right here. Now, since we know that AB is the diameter, we can use angles in a semicircle. That means that angle C is also going to be 90 degrees. So we got our three angles, they are all 90 degrees. Okay. 10.2.2, give a reason why MS is parallel to BC. This is the question. Let's just look at where MS is. MS is this line right here, and BC is this line right here. Now we just worked out that S1 and C are 90. So we can join that and we're finding another letter F. So why are they parallel? Because they are corresponding angles. Okay. 10.2.3, write down the ratio of AS to SC with a reason. Now, if we look at this triangle right here, and this triangle right here, those triangles are going to be similar, right? And we know the theorem. I can just sketch this out quickly for you. If those lines are parallel, right, and you have a common angle, so ACB, and then here is SM, and that was 6. That's P minus 1, then that's P, right? We can see quite clearly here that this is going to be line drawn from the center. If that's P and that's P, then SM is a line drawn from the center. And then that's going to make the ratio 1 to 1. So here, 1 to 1, reason, line drawn from the center. Okay? Final two questions now. 10.2.4, write down the length of MS with a reason. So MS is this line right here, that line right there, and we know the theorem now. Line drawn from the center is going to be half the line at the base. So if the base is 6, if BC is 6, that means that MS is going to be half of 6, which is 3 units. Midpoint theorem. Okay? 10.2.5, calculate the value of P. To calculate P, what we'll do is we'll focus in on this triangle right here. We can use Pythagoras to solve for that triangle. So remember, P is my hypotenuse, so P squared is going to equal 3 squared plus P minus 1 all squared. P squared is equal to 9 plus P squared minus 2P plus 1. P squared will cancel. You take the minus 2P over. 2P is equal to 10. P is then equal to 5. And that's it. If you found it useful, if you like this video, please leave a like, share, subscribe it with your friends, share, subscribe, and if there's something specific you want me to do, let me know in the comment section below. Until the next one, bye. And that's it for this video. If you liked, and that's it for the video. If you found it useful, please leave a like, share, subscribe, let your friends know about it, hit that bell icon, and if there's something specific you want to, okay, 3, 2, 1. And that's it. If you found this video, 3, 2, 1. And that's it for the video. If you found it useful, please leave a like, share, subscribe, hit that bell icon. If there's something you want to know, a question you want me to answer, let me know in the comment section below. And until the next one, bye.